Okay, ladies and gentlemen, so today we're going to get into our next lesson, which is a lesson on volume of cylinders, right? And this is something that we didn't do last year, but it's very much related to what we just reviewed with our volume of prisms. So a cylinder is a three-dimensional shape with two circular bases. Right? It kind of looks like a can. And if you see here, we have one circle at the top and then one circle at the bottom. Composite solids are when we put two or more three-dimensional shapes together. And we looked at that at the very end of last night's lesson when we did in our lesson summary. Okay, so in words, the volume of a cylinder with the radius r is the area of the base times the height. Well, in this case, our area of a base is a circle, and we know from last year that in order to find the area of a circle, it's pi r squared. So you can either write the formula as volume equals big BH. Big B, again, stands for the area of the base. Or you could write it as volume equals pi r squared h. Either one is going to work for you. Okay, so let's just get right into some practice. It says round your answer to the nearest tenth. We're going to use the pi button on our calculators unless it tells us otherwise. So find the volume of the cylinder, round to the nearest tenth. So we start with our formula. I'm going to use the pi r squared h. So we're going to have pi. My radius, and remember radius is halfway across the circle, so 5 squared, and then my height is 8.3. And that, again, can be put all into your calculator. And hopefully you know where that pi button is on your calculator. So pi times 5 squared times 8.3. And I'm going to get 651.88, but it wants it rounded to the nearest tenth. So there's the tenth space. That second 8 tells me I have to go up to a 9. Labels are still the same because it's a volume, so 651.9 centimeters cubed. Find the volume of a cylinder with a diameter of 16 inches and a height of 20. Well, my formula, I need a radius. So if a diameter is 16, if you remember, that means your radius is half. So your radius is going to be 8 inches. My formula, pi r squared h. So then we're going to have pi, because that's reminding me to use the pi button, times 8 squared times 20. Still wants it rounded to the nearest tenth. So when I put that into my calculator, you are going to get 4,021.2 inches cubed. Okay, let's try another one. Oh, got to go to the next page. These look like they're really long, but it's because the pictures take up so much space. So the metal paperweight is in a shape of a cylinder. The paperweight has a height, there's your h, of 1.5, a diameter of 2 inches. All right, well, that means my radius is going to be 1 inch. How much does the paperweight weigh if 1 square inch equals 1.8 ounces? Except that should be 1 cubic inch, because it's a cylinder. So this should be if 1 cubic inch weighs 1.8 ounces. So we'll get there. Let's find the volume first. So I know my volume is, pi r squared h, pi button, radius we already figured out is 1 squared, height they told me was 1.5. So when I put that in my calculator, we're getting 4.712. I'm not going to round until the end. So this is inches cubed. Well, Each inch cubed weighs 1.8 ounces. So this is like a unit rate. Okay, so if I'm looking at if one weighs 1.8 ounces, if I have 4.712, I have to do 4.712 times 1.8 to see how much it weighs altogether. And that's going to give me 8.48. That 8 tells me to take the 4 up to a 5, 8.5 ounces. So again, they wanted us to go a little bit further, do a little bit more with it than just find the volume of the cylinder. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1.5, so I need half of that. So my radius is 0.75. The container is full. How much do the contents weigh if the average weight of an aluminum can is 37 ounces per square foot? Round to the nearest tenth. I don't understand why it's saying that. Okay, we're just going to continue on. So volume is going to be pi r squared h. We have pi, my radius is 0.75 squared. My height is 4. Okay, so that means the volume of my container is 7.07 inches cubed. Okay. How much do the contents weigh if the average weight of an aluminum can is 37 ounces per square foot? Okay, you know what? We're going to come back to that one and work on it in class together. So we will finish that. Leave it as it is for right now. Let's take a look at another example. Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of each bead. So now what's happening is we're starting off with this beautiful cube, but I've drilled a hole through it. Okay, so that means then that we don't have the full volume. This is similar to a composite figure, except we have to find the volume of the cube and then the volume of the cylinder, and we're going to subtract those. So my volume of my cube is what we reviewed yesterday, length times width times height. These are all, because it's a cube, they're all the same. So 12 times 12 times 12, which, when I do that in my handy-dandy calculator, is 1,728 millimeters cubed. So this is for the cube. Okay, now, again, think about a bead, right? You've seen these. So now we have this hole through it. If you notice, this diameter here is 2, which means my radius has to be 1. So now I'm going to find the volume of the cylinder, pi r squared h, which is, let's see, pi. So my radius is 1, and my height is still 12, because it goes all the way through. So second pi times 1 squared times 12 gives me 37.7. I'm rounding to the nearest tenth again. So we started with this big cube, well, not big, but we started with this cube that had an area of 1,728 millimeters cubed. We drilled a hole in it all the way through that was 37.7. We're basically saying, well, how much is left over? So I have to subtract those to find the volume of my bead. Minus 37.7, and I'm being lazy, I'm putting it totally in my calculator. 1,690.3 millimeters cubed. So again, this is a composite figure where we're taking, and we have two different solids. This time, though, we're taking them apart. In this example, we're going to be putting them together. A service club is building models of storage chests like the one shown to donate to a charity. Find the volume of the chest to the nearest tenth. So on the bottom, I have this lovely rectangular prism. We did that yesterday, length times width times height. Then on top, I've taken and I've put this kind of half of a cylinder. So we'll do that one in a second. So here's my length, my width, and my height. 30 times 25 times 50. So 30 times 25 times 50 is going to give me 37,500. Okay, so that's for the prism. Now I have to do my cylinder. Well, my cylinder is pi r squared h. But I have half of it, because see how they kind of took it and I don't have a full cylinder? I only have half. So I'm going to say then divide by 2 up here. I have to be able to figure out my radius. Well, if you look here, this is your diameter, which is the 25, which means your radius is half of that, which is 12.5. And again, we did this all last year, that part of it anyway. So we're going to have pi times 12.5 squared. The height is how far back this is going, which is your 50 centimeters. So you have to make sure sometimes that we're getting the right numbers. And then I have to divide it by 2 because I only have half. So pi times 12.5 squared times 50 divided by 2 is going to give me 12271.8. I'm rounding to the nearest tenth because that's what it told me to do. Centimeters cubed. So now I have to add these two together because I need the prism on the bottom and the half cylinder on top. So 37,500 plus 12,271.8. Add those together. 49,471.8 centimeters cubed. Okay. Any questions? Bring them to class. Hopefully that was nice and easy for you. I hope. Have a good night.